The global environment around us is dynamic in all its aspects. It is necessary for the nations to constantly keep pace with the activities happening within and around them. A majority of nations have realized the importance to be prepared for all possible scenarios, and India happens to be one of them. There are various chaotic systems prevalent around us that make the monitoring and study of our surroundings complex. These differ from region to region and have varying impacts, both short and long term. Established in 1988 by the Council of Scientific and Industrial Research, or CSIR, the Center for Mathematical Modeling and Computer Simulation, or Cmmacs, was formed to harness mathematical modeling and computer-based simulations to address many complex problems of scientific significance and societal benefits.
Throughout history of science, mathematical modeling has played critical to enabling roles. With the advent of high-performance computing, the applicability of mathematical modeling to real-life problems has increased manifold. CSIR was quick to appreciate the opportunities brought in by mathematical modeling, and thus Cmmacs was born in 1988 to bring in these new tools and new opportunities to CSIR and to the nation. The recent advent of large datasets, both from observations and from simulations, have opened up new opportunities and challenges for the Institute. In its repositioning as the CSIR Fourth Paradigm Institute, the Institute has a much larger mandate and varied scope. With a number of groups engaged in complementary and multidisciplinary research, with its generic expertise in computer simulation, mathematical modeling, and data analytics, CSIR 4PI now addresses a large spectrum of problems of societal and industrial relevance.
CSIR Cmmacs has been repositioned as the CSIR Fourth Paradigm Institute with the focus on data-intensive scientific research.
When we look at phenomena happening deep under the ground, leading to earthquakes, or deep in the atmospheres, leading to climate changes and changes in the monsoon patterns and so on, these have been extremely complex phenomena to be captured in the computer with the high-performance computing systems that we have at place here. The results that we have been able to get over the past 25 years in these fields have been fairly remarkable, and some of them are pioneering in our country. For the first time, GPS has been initiated in this laboratory in the nation to study the crustal deformation studies. The effect of this is finally that the laboratory has been able to estimate to millimeter accuracy how much the Indian plate is moving towards the Himalayas.
Carbon is essential to life on Earth, although rising levels of carbon dioxide and other greenhouse gases by natural or human activity can cause drastic changes to the global environment. The scientists of Cmmacs investigate and integrate the several components of the carbon cycle that includes oceanic, terrestrial, and atmospheric components, and study the key processes in the carbon flow with the help of high-precision data and relevant models.
The link between greenhouse gases and global warming has been established by the IPCC very well. While we know the sources of anthropogenic greenhouse gases, we do not know their sinks so well, and in short, we are unable to close the greenhouse gas budget. We know that there is a vigorous cycling of carbon between all the compartments of the Earth system, land, ocean, and the atmosphere. If we can model the processes that lead to these interactions as completely as possible, we can close the budget. At Cmmacs, we've been conducting intensive research on the atmospheric and oceanic parts of the carbon cycle. We have combined accurate measurements of atmospheric carbon dioxide with an inverse model to yield robust estimates of sources and sinks. These are expected to formulate policies for mitigation of climate change and emission control.
Measurements have to be made at relatively clean sites which are reasonably far away from large local sources such as major cities. Coastal stations are preferred as both continental and ocean air masses are sampled. Keeping all these points in mind, 3 continuous measurement stations for greenhouse gases are set up in Hanley, Pondicherry and Port Blair, where the data is collected at every 5 seconds. For CO2 and CH4 concentrations, at Port Blair we have another instrument measuring N2O and CO concentrations every 5 seconds. All these data collected by these instruments are downloaded at Cmmacs for further analysis and modeling. So this is an air sampling unit where we collect air and measure and the concentration of the composition of air, like all the gases that we are going to do. So how we do is we just take a 1 liter glass flask, we fix it on this air sampling unit. We generally collect once a week. We collect the air from the top of the tower which is fixed at the station. Take this tube, we fill in the magnesium perchlorate, the chemical which takes the moisture out and passes the dry air through this tube. The tube from the tower which comes from there, it gets connected to this, and we switch on the pump here and it sucks the air and send it for analysis.
The oceans are major sinks of carbon, and along with the marine ecosystem play a pivotal role in the study of the carbon cycle. The marine biolife contributes greatly to the global carbon cycle as they are responsible for the transfer of inorganic carbon from the surface of the ocean to the other layers and its conversion into organic carbon. Long-term responses of the ocean system to global change scenarios can be researched with a combination of accumulated data and relevant models.
In the oceanic component of the carbon cycle, oceanic living beings called the phytoplankton fix the carbon in the presence of nutrients and light during photosynthesis. These lie at the bottom of the marine food chain and then are consumed by higher trophic levels, and bacteria will remineralize whatever is the organic carbon fixed in the ocean. In addition to the interaction between biology and chemistry, they also determine the partial pressure of carbon dioxide in the ocean, which is going to influence the AC flux of carbon dioxide. Acidification of the ocean due to the uptake of carbon dioxide is also studied using the modeling and simulation of marine biogeochemical cycles. The systems and models we have in place will let us know the answers for some what if questions. What would happen if all the nutrients were consumed to generate organic matter? What would be the effects of climate change on marine biota? This kind of questions can be answered with the modeling of marine biogeochemical cycles.
Earthquakes can lead to widespread destruction as observed over centuries now. These vibrations or seismic waves that are caused due to the breaking of rocks at a point along a fault and moving in all directions through the earth. Since 1994, Cmmacs has been involved in the field of GNSS, or Global Navigation Satellite System, to have better constraints on the active tectonic deformation happening in and around the Indian plate. GPS measurements for the past 2 decades have led to several pioneering achievements in qualifying the kinematics of the Indian plate. The Solid Earth Modeling Group focuses on precise GPS-based qualification and modeling of inter, co, and post-seismic surface deformation of the Indian subcontinent.
GPS stands for Global Positioning System, which is now renamed as Global Navigation Satellite System. What GPS does is it gives you the position to millimeter accuracy. So once we get the position of any point on the earth with millimeter accuracy, then we know the motion of that point over a period of time. We have over the past 20 years, we have done pioneered research using global positioning systems for studying the deformation of Indian plate, which basically leads to the earthquake hazard quantification of Indian subcontinent. we were the first to measure in 1994-1995 using a station in Bangalore the motion of Indian subcontinent, that is the position, the motion with which the Bangalore moves, that is 5 centimeters per year. That was the first time in the world this motion was measured so precisely using global positioning system. If on the surface the deformation is 2 centimeters per year, you say what is that is causing below the surface this deformation. That is our main research focus in our group. And we have also modeled during this period of study, we had 2 major earthquakes, that is the Bhuj and the Sumatra earthquake. So during an earthquake, how much the deformation has occurred? Like for Andaman Sumatra earthquake, the Andaman islands have moved up to 6 meters horizontally and up to 1 meter vertically. So using that motion, we can actually model how much is the subsurface rupture, how much is the extent of rupture which was caused by the Sumatra earthquake, which caused this 1 to 6 meters deformation on the Andaman Islands.
The scientists from Cmmacs monitor benchmarks around active volcanoes using GPS technology and use the data to measure the rise of the level of the magma by inverse mathematical modeling. GPS technology has led to future research into extreme weather phenomena.
Through the delay which encounters in the ionosphere, signal delay in the ionosphere, we have estimated total electron content of the ionosphere, which will be useful to study the inaccuracies in navigation and positioning. In addition to that, it will be helpful to remote sense the variabilities in the ionosphere, which is caused due to the earthquakes or tsunamis or any other acoustic gravity waves which propagates up to the ionosphere. Precipitable water vapor can be used in quantitative precipitation estimates, especially in terms of cloudburst, extreme rainfall and forecasting of that. And similarly, the ionospheric total electron content can be used to remotely sense the arrival of tsunami and even the earthquake precursors to study about it, and which eventually helps us to understand the enigmatic theory of seismo-ionospheric coupling.
Earthquake hazard assessment, the mapping of the impact of ground motion, monitoring of surface faulting, liquefaction, and landslides are done at this institute. The scientists here have set up broadband seismometers at strategic locations across India and constantly monitor the data being collected.
Here at our institute, we are the first in the country to prepare the deterministic seismic hazard map for the entire nation based on the modeling and simulation of very realistic complete synthetic seismograms. We study the subsurface geological structure and lithosphere modeling using broadband seismology. We have set up the arrays of broadband seismic stations and record teleseismic, regional and local earthquakes used to study seismic tomography and crustal and mantle structure. The subsurface sedimentary deposits can amplify the ground motion because of trapping of seismic waves due to impedance contrast between sediments and underlying bedrocks. Such mapping is being carried out in megacities or large urban areas using microtremor or ambient noise, and we do 2D or 3D modeling of site-specific ground motion hazard, also called microzonation. Whenever we speak about a natural hazard, earthquakes are the most catastrophic events that occur without any warning and result in great destruction and loss of lives. We are still not in a position to precisely predict an earthquake, and hence the only way to mitigate the destructive impact of these earthquakes is to conduct a seismic hazard and risk assessment and take the precautionary measures. That means one should predict the impact of these earthquakes on a particular site or zone or region in terms of expected ground motion. Here at our institute, we are the first in the country to prepare the deterministic seismic hazard map for the entire nation.
India, with its climatic diversity and vulnerability to climate change, needs urgent efforts to create a meaningful knowledge presence. Though India has fallen short of the global average of climate change-related research publications since 2000, the 11th Five-Year Plan project of CSIR on Integrated Analysis for Impact Mitigation and Sustainability, or IAIMS, a network initiative among a number of institutions and academia, aims to develop a multidisciplinary platform in climate change research.
CMP of Cmmacs is founded on the principle of sustainability and prosperity for all through actionable knowledge and what we say technology innovation. Growing population leading to saturation or even decline of resources has made certain adaptation options like migration unpractical. At the same time, while human activities have emerged as strong external forcings in the climate system, technology has evolved to design mitigation strategies to reverse some of the effects of anthropogenic forcing. However, adaptation and mitigation, these strategies need to be proactive, based on actionable knowledge and implementable solutions. To achieve this goal, CMP has adopted a combination of generic mathematical modeling, data-intensive research, technology innovation, and outreach.
The issue regarding incessant rains across regions and the sharp decrease in areas that receive all of India's average rainfall is a huge issue for millions of Indians. The Climate and Environmental Modeling Program, or CEMP, strives to monitor and study these aspects and other changes in climatic conditions in order to provide proactive solutions that have a key to sustainability from a national perspective.
CEMP has established a GIS laboratory to analyze and present data and information at user and application relevant scales. The GIS is an important part of a decision support system under development. The remote monitoring system at CSIR Cmmacs is connected to CSIR common network of automatic weather stations. The real-time weather parameters like temperature, radiation, wind, humidity, rainfall, etc. from the automatic weather station are received at CSIR Cmmacs, and a remote health monitoring system is displayed in our center along with the data stored in the high-performance computing archives.
The CEMP is the global pioneer in the ever-challenging area of dynamical long-range forecasting of monsoon.
It is critical that a calibrated and validated climate projection platform integrating processes like energy and health is developed for India. Our team here at Cmmacs has developed methodologies by calibrating and validating a general circulation model for the advanced and reliable forecasting of monsoon over India.
Anomaly forecasting and regional forecasting, which are used toward better energy, health, water, disaster management, and agriculture planning. The Hobli level forecasting, currently addressing cluster of villages in Karnataka, covering about 10 square kilometers, is soon to be extended to the Panchayat level and other regions. Associating with the Karnataka State Disaster Monitoring Center, they generate forecasts every 24 hours, which help farmers plan for irrigational purposes and pesticide usage.
Weather informatics and forecast system will have enabling effect in areas like crop insurance. It will also provide significant economic benefits to farmers. Avoidance of a single episode of unnecessary irrigation not only saves water, but approximately 30 crores for a farmer base of 1 lakh. The economic benefits for a total base can even be more significant.
With a decrease in arable land and other resources in India, it is important that productivity is increased to maintain balance. CEMP has therefore developed a dynamical model to study agricultural self-sustainability, taking into account factors such as trends in surface water, population, and climate change. To aid water stress management in India, the CEMP, in collaboration with other partners, have pioneered ground-based water cloud seeding. Due to the effects of climate changes, linkage of climate variables is required to adapt to and mitigate relevant effects. Common is a multi-institutional effort involving the participation of several agencies, leading to a source and knowledge-sharing framework with the available and gathered data from over 25 sensors installed on towers across the country.
thanks to the concerted and synergetic efforts by Common Research Alliance, a unique knowledge infrastructure with critical data in the area of climate monitoring and modeling has been successfully developed and maintained. Critical science issues like reliability of projections can be only achieved through multimodal simulations. However, generation of multimodal climate projections is very effort and computing intensive. A fourth paradigm sort of approach will be adopted to supplement in-house simulations with synthesis of multimodal, multiple scenario simulations available in public domain, calibrated and validated through common data. Critical science issues as well as reliability of projections can be only achieved through multimodal simulations. However, generation of multimodal climate projections is very effort and computing intensive. A fourth paradigm approach will be adopted to supplement in-house simulations with synthesis of multimodal, multiple scenario simulations available in public domain, calibrated and validated through common.
Only a network like this can provide multi-level, comprehensive and sustained observations that lead to calibrated and validated regional climate model. Megacities have various factors affecting the local weather. The mesoscale structure can be studied from the high-density observations available through common to monitor extreme weather events and design efficient energy and transportation. Fog, a high-impact weather event, has immediate effect on air and road transport. Under the mesoscale observation network for urban system, a study carried out on a fog formation at Delhi has provided the very first opportunity for examining the relationship between dynamic meteorological variables and the occurrence of fog. The malaria vector mosquito can be monitored and controlled by studying weather variables which contribute in spreading the deadly malaria. The scientists at CEMP have developed simulations after process identifications, impact analysis and evaluation of the major atmospheric pollutants over the national capital. Carbon sequestration is the process of capturing and long-term storage of atmospheric carbon dioxide or other forms of carbon to either mitigate or defer global warming. The vetiver plant, studied by the scientists at CEMP, has proven to be an effective method of terrestrial sequestration in India.
We have been able to assess and develop a system which involves a perennial aromatic grass called vetiver to sequester atmospheric carbon dioxide.
Cmmacs are the pioneers in the prediction of advanced cyclones in the North Indian Ocean. Several state-of-the-art models have been integrated by real-time forecasting of intensity and tracking of tropical cyclones.
Tropical cyclone had significant impact on the Indian economy, agriculture, life and property due to its devastating nature. Predicting tropical cyclone track and intensity has been a challenge over the North Indian Ocean. Here we have simulated more than 50 cyclone cases over North Indian Ocean using state-of-the-art mesoscale model as well as high-resolution global circulation model. We have shown that the model domain configuration and its parameterization scheme plays an important role in simulation of maximum intensity, track as well as spatial structure of the cyclones. A large number of processes and factors control the quality of simulation with mesoscale models. Identification and optimization of these processes can improve forecast skill of the tropical cyclone, which can save the life and property of the common man by adaptation and mitigation processes.
Many places in India are vulnerable to heavy rainfall events and associated flash floods, which are caused by interactions of many processes at different scales, from large scale circulations, low pressure systems, mid-troposphere cyclones, and local instabilities. Under CEMP, we have identified relative roles of large scale and land surface processes on the origin of the extreme rainfall events through simulations using high resolution general circulation model.
Proactive adaptation and mitigation of climate impact on different sectors like health, energy, agriculture, economy, and even other sectors is only possible through reliable projections at relevant scale. A critical requirement for actionable knowledge is robustness, reliability of the projections and the scenarios. This can be achieved through multi-model and multiple scenario simulations. As such, multi-model simulations are effort and computationally intensive. A fourth paradigm, it's a new approach, will be adopted to mine and synthesize these simulations available from sources like IPCC to complement in-house high-resolution simulations. Sustainability and adaptation are, however, primarily local issues involving local resources as well as practices. Besides, climate variability has strong geographical variations. Thus, projections of climate change need to be at relevant spatial scales for applicability. Even high-resolution climate projection may represent fields averaged over large areas or for practical implementation. These issues have been addressed through algorithms for downscaling, calibrated and validate a particular locations over India to generate local solutions.
The multi-scale modeling department at Cmmacs focuses on the simulations of high-resolution long-term climate projections.
Multi-scale modeling is a data-intensive paradigm where numerics and computing strategies relevant for different scales in any dynamical system are combined to arrive at a more effective solution than the one that can be obtained from a single computing strategy dealing with the relevant single scale. It is applied to varied fields such as material research, engineering, and computer science. At present, the group is focusing on multi-scale phenomena in atmospheric science. For example, organized or rain-giving convection is a superposition of convective variability in different spatio-temporal scales. These waves and their multi-scale interaction needs to be represented by any global dynamical model for accurate weather and climate simulation, and most importantly for reliable climate change projections. Fundamental barriers in this are mainly due to limited capability of numerical models to represent this multi-scale organization of convection. A necessary condition for rational solution of simulation problem is sufficiently accurate knowledge of the laws according to which one state of the atmosphere develops from another. Numerical modeling of the atmosphere has been and still is a struggle for establishing such laws, especially for modeling multi-scale atmospheric processes.
In collaboration with the French Centre National d'Études Spatiales, data received from the Megatropique satellite is utilized in understanding tropical meteorological and climatic process.
Utilizing large amount of observation from satellites, observational campaigns, and analysis such as tropical rainfall measuring mission of NASA, USA, and JAXA, Japan, Megatropics mission of ISRO, field campaigns of MOES, and ISRO Aeronet satellite observations of aerosols and their optical properties, we attempt to improve our understanding and develop algorithms for cloud rainfall processes and aerosol radiative transfer in the atmosphere, and then to incorporate these processes in the physics modules of the GCM. The modified schemes of the GCM will then positively feed back onto the characterization of climate variabilities simulated by the model. Realistic representation of aerosol feedback is crucial to simulate reliable climate change projections of rainfall and extreme events due to global warming, which is one of the primary research areas of our group.
Computation is the third pillar of modern scientific research.
In the mid-80s, when the technology was denied to us, one of our own scientists, CSIR scientist, Dr. UN Sinha, and his team have developed India's first parallel computer in CSIR NAL. So CSIR has been in the field of supercomputing for a long time now, and CSIR Center for Mathematical Modeling and Computer Simulation has been the provider of high performance computing facilities for the whole of CSIR for a long time. We have more than 20 years of experience in doing this with a very high uptime efficiency of the supercomputer, more than 98% availability of the resource.
The facility at CSIR Cmmacs is one of the fastest in the country. It provides computational capabilities in different fields of computational sciences such as biological, chemical, engineering, earth, atmospheric, and physical sciences.
The HPC system Ananta installed at CSIR Cmmacs is currently the fastest in CSIR and is theoretically capable of computing a peak of 362 terafloating point operations per second. However, the sustained performance achieved by the system using a standard high-performance LinPack HPL is about 303 teraflops. The system is a cluster of 1088 computing nodes distributed over 17 racks. These nodes are connected to each other using high-speed FDR InfiniBand interconnect in a non-blocking fat tree topology. The highlight of the data center is the cooling infrastructure based on ultra-modern water cooling mechanism through rear door heat exchangers RDHX. The indoor HPC infrastructure is supported by an energy farm consisting of chiller plants, diesel generators, high-speed diesel yard, compact transformers and other electrical infrastructures such as the UPS and power distribution unit.
High-performance computing, popularly known as HPC, has been a thrust area in CSIR for the past 25 years. It's a mandate of CSIR 4th Paradigm Institute to provide world-class HPC access to its computational scientists who are able to leverage the power of HPC installed at this institution.
Cybersecurity and cryptography continue to be one of our active areas of research. This is indeed a complex domain of high global and national importance. As all of us are aware of today, cybersecurity has a direct impact on both our personal privacy and national security. So during the past 1 decade, we have been focusing on certain unique aspects of cybersecurity, which include security analysis of current and next generation communication protocol on the internet, identification, simulation, and visualization of sophisticated cyber attacks like low-rate flooding, denial of service attacks, and their distributed variants. Our team, for the first time, identified and demonstrated a new threat, which we named induced shrew. Induced shrew is actually a new variant of low-rate flooding denial of service attack, in which standard and non-compromised servers are exploited as flood sources. As far as our ongoing and future activities are concerned, we recently initiated a well-focused cyber security research program called CISRO, which is funded through the CSIR 12th 5-year plan.
Recently, we have been focusing on cloud, mainly its security implementation, security assurance, and trust. These are the parameters which plays a major role in its success as a business model. Also, we have been working on some cloud applications which are useful to common men, like e-healthcare and flexible cloud payment models for the cloud system. One of our most recent work is focusing on the 4th paradigm research, especially devising methods, techniques, tools, and algorithms to handle big data and its analytics. This research will not only help the cybersecurity and cryptographic research, but also in other domains of research of our institute.
In order to keep pace with growing needs of CSIR, the HPC group has plans to install a petascale computing infrastructure in the near future. As CSIR looks forward to embrace 4th paradigm science as its future path, the role of HPC will shift from being a mere support infrastructure to as one enabler. As such, the HPC group will play a critical role in the years to come.
Within the Cmmacs structure is the Computational Mechanics Department, which studies elements in relation to fluids and how they react with each other by creating models for them. These tools of mathematical modeling and computer simulation are used in diverse areas of engineering.
There is a property in physics called chaos, which says that small changes in initial conditions and small changes in parameters can lead to very widely different solutions as time progresses. Right, but these solutions will not go beyond certain bounds. They will not be periodic, that means they will never repeat themselves, but they are very sensitive to initial conditions. Small changes will lead to widely different trajectories. What we have shown is that sometimes that even a small change in one of the elements of a system can result in huge macroscopic changes of the system taken as a whole. Since this is a problem that probes the foundations of the statistical mechanics of driven systems, it has wide-ranging implications for a number of areas ranging from physics to engineering to economics to sociology.
Using our own supercomputer, we have successfully simulated the mechanical behavior of carbon nanotubes and graphene sheets. Once we do have our own molecular simulation results, then it is possible to improve the continuum mechanics model to simulate the exact behavior of the carbon nanostructures. One of our major research areas is finite element analysis. It is a numerical method to analyze any structural mechanics problem. In fine art, Cmmacs contributed mainly for the benchmarking, validation of finite elements and development of composite elements, etc.
This form of sophisticated mathematical modeling, aided by the powerful computing and visualization, has a lot of potential. Some of the areas where modeling and simulations can play critical to enabling roles, cost-effective solutions, process optimization, and product design. Cmmacs as an institute works towards the future of our country in every sense. Not only do they contribute through the work they do, but they also share knowledge to the students who wish to serve the nation as well. Through their Student Program for Advancement in Research Knowledge, also known as SPARK, students from all over the country are given an opportunity to intern, carry out their thesis work, or undergo summer trainings at Cmmacs. It also helps Cmmacs to establish a link with academic institutions and provide students with a platform to access the best and current research work, including remote access to one of the fastest supercomputers in the world. The Academy of Scientific and Innovative Research, also known as ACSIR, is an institution of national importance established in 2011, offering PhD and postgraduate programs aimed at helping thousands of aspiring students across India. At the Cmmacs campus, students are provided with world-class programs in the field of science and technology, with access to the best minds in the country.
In addition to the expertise gained at the CSIR Fourth Paradigm Institute in areas of earth sciences and engineering sciences, we plan to diversify into other areas of science such as biology and other such areas. And we also plan to involve ourselves in big data analysis. Big data analysis, which is now called the fourth paradigm of science, is an area in which we look for patterns in large amounts of data. In regions where such data are not available, we plan to use our mathematical models to generate such data and look for patterns in those data. In addition, there will also be a fundamental group which will be working on developing new mathematical tools and will also continue to enhance the expertise we already have in earth sciences and engineering sciences.
Several collaborations and tie-ups ensure that the best resources are shared and used towards the benefit of science and society globally. The combination of data-intensive and scientific work implemented by the most brilliant minds is bringing us closer to understanding the chaotic systems prevalent around us, the large implications of which include improvement in disaster management, economy, livelihood, global environment, and the overall quality of all life on this planet.